thank you for the introduction. Today I'm going to talk to you about our donkey cars, and I call this talk Super Donkey Cars because we have the aim to improve upon the original implementation of donkey cars. But basically, it's our excuse to play with deep learning in the real world. So no pictures, no nothing. It's a car, and we're going to make it drive automatically. So what's my story? So my name is Niels. I'm the CTO at GoData Driven. I think it's a company most of you are familiar with. We do data science and data engineering consultancy. So if anybody's looking for a consultant, call us. I have a PhD in parallel computing, but basically I drink coffee a lot and wait for CloudFormation to deploy, do Dockers and EMR and Spark. It's a lot of waiting the whole day, but I'm having a lot of fun doing it. So what is a donkey car? So donkey cars it's like an open source self-driving platform for small scale cars. It's a fancy sentence, but basically it means it's like an open source community built around one, let's say, platform, which allows you to very easily create your own self-driving car. And I think that's the part which is most important from this talk, is that it's ridiculous how easy it is to build such a car once you get hold of all the components. They say it's roughly $200 to build. Once you import all the stuff here in the Netherlands, it's roughly 220 euros, but that's the import tax for you. So, but why are we doing this? So it's my excuse to play with deep learning. But it's also really nice that it's all off-the-shelf components. It's written in Python, so it's easily customizable. And it actually has a small community around it. So there's a Slack channel, you can ask questions, there's quite a few tutorials, the documentation is really well written. So that lowers the barrier of entry of building your own self-driving car by a ridiculous amount. As a side note, so we do use deep learning at clients. An example is this picture on the right. And Dirk, who's from Royal Flora, is going to present tomorrow, he's over there. At 10:50, I got a sneak preview of his talk. I think you should go there. So if there's a recommendation to be made, go to the talk of Dirk. No pressure. Okay, so let's go ahead and build our own donkey car. So like I said, the documentation is really well written. So there's this read to docs, how to build your Donkey 2. Then build the first version as well. This is the improved one. And basically what they say, it's easy. It's 6 steps. You assemble the hardware, you install the software, you do some calibration, you start driving, training, and everything is done. So let's start with buying and assembling the hardware. So basically it's built around this Exceed magnet car. Exceed is apparently a brand of RC car. You buy it, it's not really available because since they started building these kits, all of them are sold out to the geek community, I guess. So actually, we were monitoring the Slack channel. One guy posted, oh, there's some inventory over there. We just bought 2 and imported them and looked at the cost later. But that's basically the most difficult part to get, the RC car. Step 2 is actually printing the frame itself, so this, the orange part. And we actually use 3D hubs. I know they're a sponsor here as well. It's a coincidence, I didn't know before. It's really nice. So you just upload making a commercial now, but anyways, you upload the models to this website, and there was a guy in IJsselstein who had a 3D printer. He printed these things for me. It was really quick, and I liked it a lot. So also this 3D, the nice thing of this frame is that it's designed for the car. So it just builds on top of it. So then the next step is you remove this plastic shell of the car. And you disconnect the receiver. It's a bit small. There's like the original car comes with a RC receiver. It just has 2 jumper wires in there. You just remove the jumper wires, plug off the shell. Then you need to assemble the frame basically. So you assemble the frame, you bolt on the Pi, and you bolt on the camera and the USB battery to power the Pi, and plug in the motor controller. And it's those 2 jumper cables you just removed from the original RC receiver. You just plug them into the motor controller, and that's it. So there's no soldering iron involved. You pick up the jumper cables, you plug them in, the car is done. This is amazing, again. So what do you then get? Like I said, so there's a camera at the front. It's like this wide angle camera to get a nice view of the track. You have a USB battery powering the Raspberry Pi. It has to be a certain amperage, but it's all clearly written. You have the Raspberry Pi. I think most of you are familiar with it. And there's a motor controller. We bought most of the components off Amazon. If you want to go, if you order it from China, then probably it's even cheaper than what we did. So the next step, you can use any Raspbian image. They have a pre-made image, but if you use Raspbian, you need to pip install the package. Okay, so you have to actually use master, but yeah, that's fine. And after installing the package, it will install TensorFlow, Keras, a lot of these neural net dependencies. And it will give you this Donkey CLI, which allows you to easily create new cars, which are, they're like, you can have multiple cars in, it's like a subfolder they create. You have to calibrate your car before using it. And they have this concept of tubs, which are basically data sets. You can make a movie out of a tub. I'll show all of them in a bit. So after creating a car, like I said, it basically builds like this subfolder. So here I'm creating a car called D2, Donkey 2. It makes these subfolders, so for models, data, and logs. So models stores your models, data stores your data sets, and logs is, it logs some stuff about that we're having dropping frames and that sort of stuff. But I think most important is that it creates this config default. So this line, and you actually need to adjust those before you start. And adjusting those means that you basically need to learn it. So it's controlling these servos for steering and also for forward and backwards. You need to calibrate those because every car is slightly different and you have to adjust. So how do you do that? Basically, you hold the car in the air. You start inputting different these PWM values. You see how far to the left and the right the wheels turn. You get a rough estimate, and then you should do this fine-tuning. So we skipped it because we wanted to see if the car worked. But anyways, this is from the Donkey Car documentation. It makes sense to actually do the fine-tuning because what you want is let's say in the graph to the right, you want to have like a, I don't know the good correct data science word for it, but you want to have like a nice distribution in your. If you steer 80%, you want to also have a 80% turn, let's say, and not that there's a difference between turning a full lock and a bit less. So this has to be fine-tuned a bit. But it's quite easy. Yeah? So we skipped this step completely. Just looked at the wheels turning in the air and more or less got it correct. So after this calibration, you can actually start training. So you need to build a track. So first time we use some tape, but it has to be clearly visible. So I think a surface like this, some carpet which is really dark, you need to have a bright something tape to make the track visible. Then after you build the track, you start driving it around, and basically there you create your data set, your tub. So there's two ways to actually control the car. There's a web interface hosted on the Pi, and you can actually use your built-in iPhone gyro to control the car. For me, I couldn't do it, but we had a colleague who actually managed to do this. So after we actually bought this PlayStation controller, which is on the desk here as well, which allows you to control the car through Bluetooth. Helps a lot. Okay, so if you actually create this tub, you basically have to drive around the track for 10 to 20 times. You have your data set, and it's basically a folder consisting of a lot of images and this tub thing, which is basically your labels for this particular image. So these labels combined with the images are the input of the neural net you're going to train. So I have a video visualizing this tub. Oh, PowerPoint. There it is. Okay, so what you see here is the actual pictures, or the video we took while training, and the steering input is at the top. So you see left and right. So you see left or right. Yeah, and the nice thing is, again, this is provided to you through the donkey car library. So even this you just get for free, and you can easily debug and remove it. There's this split button, so if you went off the track, you can actually remove parts of your data set to not train the accident as well. So yeah, this is a great feature. So the idea is you create multiple tubs, you train your model on top of one or more of these tubs, and then you're in business. You've trained your model. So like I said, also this is included. There's a simple neural net included. I think it's like a 5-layer. I'm looking at like 5-layer neural net with some. It's pretty trivial, and by default it uses like a really low resolution images, so 160 by 120 pixels. I think it's mostly due to the compute power you have on the Raspberry Pi, because yeah, you have to inference basically on the Pi. Training takes a while on the Pi, so actually use the AWS GPU instance, but obviously that came with a newer TensorFlow. We had to recompile TensorFlow for ARM to get it running on the Pi again. And anyways, our first attempt was at least relatively successful. So this is the car now running in automated mode. And the only thing we're faking is actually the throttle. So we're doing that ourselves, which sounds like cheating, but it's actually quite a fast car. And if it goes off the track, it will do something you will not expect, because it has never seen the outside of the track. So having control of the throttle and not having a speeding car going through the office actually made a lot of sense. So yeah, like I said, this actually worked quite well. And even with the picture, I could almost start like a self-driving company, a self-driving car company now, and convince some investors to give me like 50 million, because it's more or less done. But it turned out it didn't really generalize this one model, because we had this table standing next to the track, and once we moved it, we noticed that the car wasn't turning right anymore at the correct point in time, because it didn't really learn to turn right when the tape went right. It just learned that it had to go right when the table was there. So we thought, okay, this was our first day. We had somewhat of a model. Build 2 cars, build a model. Let's spend another Friday on this. We have this concept of code data-driven Fridays, wherein we can play around basically for a full day. Let's spend another Friday on this, and then we'll do the code data-driven magic. We'll just make it better and really start this new self-driving company, car company. Okay, so next Friday, we're going to improve it. We bought the PlayStation controller because training it with the built-in gyro was really difficult. So we switched to the PlayStation controller, increased the resolution, big data, more data is, that's what you want. And we also changed the track layout because we needed a bigger track, and let's do this. So also we did a third attempt, and we decreased the resolution again, and I'm going to explain you why. So turned out it's maybe not the best idea to change too many knobs at the same time. So the second attempt failed miserably. And somebody allegedly said it was due to my driving style. I don't concur, but at least, okay, maybe it was true. And then we had a third attempt, different driver, and it actually failed because of actual reasons. So we started debugging it. And like I showed before, this is a snippet of the previous picture image. So you have the steering values, right? And this joystick we bought is really nice for driving, but it's maybe not so nice for training, because the gyro we had before, it's really difficult to go from full lock to no lock in a single go, right? You always have some intermediate values in between. But with the joystick, it's trivial, right? You just push full lock, you release the knob, and it's just 0 again. So this actually causes a problem, and it actually caused our network not to converge at all. Like the loss was ridiculous. So again, what we learned, only change one part at a time. Basically, we should have only switched the joystick and not a different track and all these things. And also, yeah, we needed to actually going to implement some smoothing function to fix the joystick, right? So if you have like a rolling mean over the joystick input, maybe we'll get over this problem of these rapid input changes. So that's the first thing we're going to implement. Second, I think it's nice to have a visualizer to see the predictions of the neural net. Like I said, we can visualize the tub. Currently, there's no built-in function in the donkey car library to visualize actually the predictions of a neural net. So I think also having that will allow us to debug the donkey car better. We're going to actually create more data sets on different tracks. And at the end, we're going to beat Tesla building first driving car based on donkey cars, because that's obviously the correct platform to test these things out. So that's now an open question. As you see, it's a very much work in progress project for us. We have GD Friday every 4 weeks. If you have a good idea or you want to help, you can join. Maybe we'll organize a small session around it. So if you send me an email or drop by the booth we have here, we can maybe have a fun day of hacking all together and actually improve these donkey cars and let everybody experience how nice it is to have this self-driving deep neural net platform. So that's also my conclusion for this talk. So again, highlighting, I think it's really nice to have access or have this open source community around the platform, which is really plug and play. Like I said, just buy the components off the internet, you plug it around, no soldering iron required. You don't need to mess about these PPM values, seeing if your controller will work or it just works. The package itself is really well written, a lot of features in there, good documentation. There's a Slack community which will help you out if you run into problems. And for us, it's really, and for me personally, it's a really great platform to test/play around with these deep neural nets in the world and seeing something move, which is also a nice tangible thing to have. So with that, we're always hiring. And are there any questions?
Yeah, so we have one question anywhere else in the room already? 2, 3. I'm trying to not skip people this time. Okay, so 1, 2, 3.
So you mentioned that you figured the lack of convergence of the second attempt was due to the different, qualitatively different input.
Yeah.
But you also made a much bigger network, right? So why do you think it's the input and not the network?
Okay, so sure, we changed the network as well. So also this problem we had with the joystick also happened with the lower resolution, and then sure we increased the resolution from this 160 to 120 to 320. But I think okay, for the maybe if we go to 1024, okay, then you have a valid point that probably the resolution also introduces some problems. But with this doubling of the resolution, I think it's okay. We changed the size of the model accordingly, and it basically what we saw while training, the first epoch, it already had like converged, which is suspicious, right? So
it did converge, but it didn't generalize, or
yeah, it converged to its, but it still had a really high loss. So
right.
Yeah. So I think, comparing, I think the biggest differences between the two datasets, the first one and let's say the third one, was the change of the joystick and having this really erratic input for the steering.
All right, well, thank you.
Okay. The second one was you, right? I'll add you as the fourth.
Hi. Is what the network that was trained, is the output directly the controls of the electronics, the steering and the PWM, the power, Or is it more sort of a higher level goal that was trained, like go there, or
No. Yeah, it's relatively directly connected to the PPM. So while calibrating, you basically set a max speed for how fast it goes, and then that's your PPM value, and then it scales it between 0 and the max output it has.
There is no logic after the neural net. It goes directly into the...
Yeah. So it's just the steering. So one further development you could do once we finished the self-driving part. I think it's also nice to have like a car which is just following persons. Let's say you can do all kinds of different neural nets with all kinds of different objectives, besides just having like a line following robot. But yeah, and I think there's multiple neural nets included. I think by default it uses something called a categorical, they call it a categorical one, which basically has 15 different outputs for the steering and the throttle.
All right.
So it's not a completely linear output.
Okay.
Question number 3.
Do you know if it works on other RC cars as well? Or is it only for this type?
I think in general it should. Like I said, I think the nice thing is that this is completely plug and play. What I have the feeling that most of these servos, they more or less work in the same way, right? They use some kind of PWM input. So as long as your servo will accept the voltages provided by the motor controller and the PWM, it should just work. Also, while calibrating, you're calibrating basically the max speed and the max left or right turns you would like to see. So that should be able to adjust to any different RC car. For instance, this one, it's really fast when it came out of the box, but for now we kept the speed to a much lower level because it's just too quick to actually run around full speed.
The quick speed would probably be used for larger tracks, but then you would have to expand and hire a lot of people and get a really, really big office.
Yeah, in the center of Amsterdam, yeah.
Yeah. Fourth question. Are there any more questions for now already, by the way? Okay. I think I see one in the back for a second.
So the question is, did you think about training on simulated data, like graphically simulated data?
Okay, so it's funny you should mention this. So there is actually a simulator included in the package. So you can actually use the simulator to generate your own neural nets from fake images, let's say. Then again, what you see a lot in deep learning is that you modify the images such a bit that it's more resistant to. I think that's really tricky to do in this setting. So if you go simulation, yes. But modifying or increasing the amount of learning examples you have, let's say, which you see a lot in rotating images or morphing them, I think that's a bit more tricky to do in this case. And also, because it's quite easy to train, I think just having multiple data sets, training on a lot of different tracks should help you there. Sure. Okay. So the question was, or the remark is that you can use the simulator to initialize your model and then more or less train on the actual data. But that's probably true. Probably that's one of the reasons they included it. I've seen people on the internet actually implementing stuff like the ability to overtake other donkey cars. I think that's if you will have to train that manually, that will be really tricky. So probably they train that in a simulator and then just basically adjust the weights to run on the particular track. But yeah.
Okay. We had a question in the back there.
Thank you. Do you have any ideas on the generalization issue to avoid it turning right at around the table?
Yeah, increase. So basically, what we did after is run the track in one direction one time and the other direction the other time. Hopefully, beating this generalization already a bit. But I think just having more and more data and at least different data. If you train the same track over and over again, it will not avoid the table problem. But if you have more data, different tracks, different settings, I think that should eventually help you overcome the problem. But in general, this is a problem of deep learning. You know that it works, and you know the input, but still there's a lot of black magic happening in between.
Okay, thank you.
Any further questions to Niels? Wow. Okay, suddenly.
No. Yeah, I think.
Could you repeat that for the rest of the room? Sorry.
Okay, so what you could do is you could remove a lot of the objects, let's say, out of the scope of the track. Let's say this table is outside of the track, so you could pre-process the images, remove all those objects, and get a cleaner data set to train on. I think, yeah, sure. What you could also do, I think there's this Comma AI. It's from GeoHot. It has like a self-driving thing you build in your own car. I think they have these line following algorithms before the deep learning actually runs. So then you have your road, the line following algorithms actually paint the colors, they highlight basically the road, the lines on the road, and then it goes through a deep learning network. That's also an interesting approach. Yeah, sure.
Okay, cool. So everyone that had a question, please raise your hand again, and then I'm gonna do left to right again. So remember your number 1, 2, 3, 4. Okay.
A simple question. Once you get the hang of the track, what's next?
Okay, so I think you can get better and better at driving a track. But what I would like is so this following people around without the track. I think that's a nice feature to have. And I also discovered there's this DJI drone. It's just a Python SDK. So my ultimate pet project would be a car following a person and then a drone following a car. So I have like this train around the office.
Actually, the drone is interesting because my use case would be things like find my keys and stuff.
Yeah, I know. So basically, this drone, it's quite interesting. It's like a €100 drone. I have a Python SDK, UDP, and you can just say fly forward, fly forward, fly forward. And if you don't say anything, it will just hover and stop. So I think it's also a nice platform to see if we can do something with deep learning and the drone.
If you figure that out while I'm building my house, then it's done when I'm done.
Yeah. You have a nice open space in the house, so that helps.
Okay, to number 2.
So what are your thoughts about using reinforcement learning? So you have some kind of sensor that detects if it goes outside of the track, and then in case that happens, you give it a penalty and use some handcrafted function to move it back to the track, and then you just go away and let it learn by itself, come back next week.
Yeah, no, it's an interesting approach. We thought about this. So I think if you were to implement that, I think you need like a separate camera, basically observing the whole track. Basically noticing that the car is outside, giving it penalty and see if you can train a model in that way. It's an interesting approach, but it's an interesting approach. I don't know if it will work, but yeah, sure, why not?
Thanks.
The next one in line is in the back. Would you be able to pass this on?
Hi, you mentioned the Slack channel, right, before? So how big is a self-driving RC car community in Europe or Netherlands?
Okay, so in the Netherlands, I'm not sure if it's that big. I know of one guy who also built one, but I think he's doing the V1. It's probably bigger than just a couple guys, but in the US it's definitely a lot bigger. So I think Amazon in their latest reInvent, they had a tutorial basically also using donkey cars to showcase their easy machine learning platform. And also there's some universities having these competitions wherein you can participate with your own donkey car-like car and see who's the quickest around the track. So it's definitely bigger, or it's a larger community in the US, but there's bound to be a couple guys here.
Thank you. And then we had one more question in the back.
So maybe a little bit related, but I think it's in the UK. You also have the Formula Pi, so it's actually competition for this kind of stuff. So are you planning joining such a competition?
Let's first overcome the low-hanging problems we're currently facing. But it should be fun. I think either joining such a competition or organizing one yourself. Why not? That's the whole point of this thing. It's also a reason why we bought two. So I brought one today, but we have two. So it should be fun to have competitions within the office already with two of the cars.
Yeah, cool.
Any further questions anywhere else?
So just maybe more of a practical thing. So for the joystick, is it that it doesn't have intermediate? Or it does have, but just the user, when it uses it, it completely goes crazy? Because is it a practicality? Like you have to put some resistance in it, like Play-Doh in it, so that it's... Well, I don't know.
I think this is almost like the second guy alleging that it's my driving which is causing the problem.
That's what I'm asking. Do you see intermediate values?
Oh yeah, there are intermediate values.
Oh, then it's the driving, right? And I've seen you drive, so maybe.
That's also, so they implemented some features as well for throttle, that it has like a fixed throttle, that you at least, because people can only do one thing at the same time, I think, so maybe only concentrating on steering. But sure, if you're really careful about it, I think if you slowly move the joystick, you'll overcome this problem.
So maybe with your driving, you should instead do a classifier, like full or not.
That could be.
Okay. With this last remark on Niels' driver skills, I would like to give Niels still a very big round of applause.